Students, you're welcome back. This is the last but one edition of our series of lessons on Circle Theorem. So in this video we are looking at summary. We are trying to summarize all that we have learned. So this is summary one. After this we look at another summary. The summary divided into two. So after this we look at the last video. So let us recall, summarize all the theorems we have looked at so far. So far we have looked at 7 theorems. So that's why we are trying to put all of them together here on let's say one sheet or one page, so that you'll be able to understand and recall, put all the theorems together. You see, so this is the first theorem. What do you recall the first theorem? Do you remember? According to the first theorem, it says that an angle subtended by an arc. So this is an arc. From this point to this point is an arc. This bigger one is also an arc. So we see that an angle subtended by an arc at the center of a circle, this angle is equal to what? Is equal to 2 times the angle subtended by the same arc on the circumference. Have you seen? So if this angle is what? A, then this angle and this angle is B, then we can say that A is equal to what? Equals to 2B. So the angle an angle subtended by an arc at the center of the circle is equal to 2 times the angle subtended by the same arc on the circumference. Okay, so we are standing at this side. So this is this arc. This minor arc is forming this angle at the center, and then this angle on the circumference. We can also use this bigger arc. So this bigger arc will also form this angle. This bigger arc will also form this bigger angle at the center, and then it will form this angle on the circumference. So if this is x and this one is y, then as with this theorem says that an angle, or the angle subtended by an arc at the center, is equal to 2 times the angle subtended by the same arc on the circumference. So it means that in this case y will also be equal to what? Y will also be equal to 2s. In this case y will also be equal to 2s. So this is the first theorem. Remember the first theorem. Yes. So the second theorem, this is the second theorem. The second theorem is just derived from what? Derived from the first theorem. So if you are saying that the angle subtended by an arc at the center is equal to 2 times the angle subtended by the same arc on the circumference. So this arc is subtending an angle, or is forming an angle of what? An angle of 180 degrees at the center. So this angle is what? 180 degrees. And then so if this is 180 degrees, then we are saying that the angle subtended by an arc at the center is equal to 2 times the angle subtended by the arc on the circumference, the same arc on the circumference. So if this is 180, then if this is 180, then 2 times this angle must be equal to 180. So it means that this one, in other words, half of this will be equal to the angle subtended by the arc on the circumference. So this one will be 90 degrees. And then since this line is is diameter, we are saying that the diameter, this is the diameter, subtends an angle of 90 degrees on the circumference. So we are saying that an arc. So we can, if we draw a line to be a chord, you can also say that the angle subtended by a chord at the center is equal to 2 times the angle subtended by the same chord on the circumference. So this time we are using this arc. This arc subtending an angle of 180 degrees at the center, and then angle of 90 degrees at the circumference. So that 2 times the angle here will be equal to the angle subtended by that same arc at the center. But we also see that this diameter is forming this angle. It means that the diameter subtends or forms an angle of 90 degrees on the circumference. Okay, so this is theorem 2, and this is theorem 3. Theorem 3, I hope you record your theorem 3. It says that angles subtended by the same arc on the circumference are equal. Angles subtended by the same arc on the circumference are equal. So this angle is equal to this, and equal to this, and equal to this, and equal to this. All these angles, all these 4 angles are equal. So this is what the third theorem. The fourth theorem also what is the fourth theorem? The fourth theorem is about cyclic quadrilateral. This is a cyclic quadrilateral, and then we discussed, or we found that cyclic quadrilateral is a quadrilateral inscribed in a circle with all the 4 vertices touching the circumference of the circle. So all the 4 vertices must touch the circumference. And then this theorem, the theorem of the circle quadrilateral says that opposite angles in a circle quadrilateral at what? At 180 degrees. So if this is A, this angle is A, and this angle is what? B. Let's say this one is what? X, and this is what? Y. Then we, from this theorem, to mean that when we add A to B, A plus B will give us what? 180, and then S plus, sorry, this is, okay, let's make this Y. S plus Y will also give us what? S plus Y will also give us 180 degrees. And then we also realize that this angle, because this angle, see, look at this angle, this external angle, this external angle will equal to Y. So the external angle is equal to Y. Why? Because this addition, when we add S to Y, you get 180. Have you seen? And then, so if this is what? If you add S to Y, you get 180. And then we know that this angle is equal to what? 180 minus S. Have you seen? So if we are saying that S plus Y is equal to what? 180. Are you see? So what is Y? Y is equal to what? Y will equal to X. This is S plus what? Y is equal to what? 180. So Y will equal to 180 what? 180 minus X. Have you seen? Y is equal to 180 minus X. So what is this angle? If this is the angle on a straight line. So if you add this whole angle, you get what? This whole angle will give you 180. So if this angle is what? X, then this side is equal to what? 180 minus X, which is what? Y. So it means that this one is equal. This is a very powerful thing in what? Circle quadrilateral, or yes, powerful thing with the theorem, with the circle quadrilateral theorem. So this angle is equal to this external angle. And then yes, so if you have let's say this one is extended, then that one will be equal to E. So we have to know this one very well. The circle quadrilateral, say the opposite angles in the what? The circle quadrilateral at what? 180 degrees. And then we have realized if the line is extended outside the circle, then this angle, the angle opposite to this one will also will go to the center of angle. Fine. So let us come to this. This is what theorem is this one? This is the alternate segment theorem. This is the alternate segment theorem. So what does the alternate segment theorem say or state? It says that the angle between a tangent. So this line is what? A tangent. The angle between a tangent is a line that touches a circle at what? At one point. So the angle between a tangent and a chord, this is a chord. Angle between a tangent and a chord is equal to what? Is equal to the angle in the triangle formed by the same chord in the opposite segment. So this angle is equal to what? It's equal to the angle between the tangent and the chord is equal to what? The angle in the triangle formed by the chord. So this triangle is being formed by the chord. This is the chord. This is the chord we are talking about. So the angle between this chord and the tangent, we are seeing that this angle is equal to the angle in the triangle formed by this same chord in the opposite alternate segment. So this one is a segment. So segment opposite to this one is the whole of this. From here to here. This is the segment opposite what? Opposite this to this small segment. And the angle in the triangle formed by this chord, which is opposite to this segment, is what? This angle. So we are saying that this angle is equal to what? Is equal to this angle. The same way, this angle is equal to what? Is equal to what? This angle. Everything is equal to this angle. This is the angle. The angle formed by this chord in the alternate segment. The opposite segment is this angle. And it's equal to what? The angle between the chord and then the tangent. So you have to note this one very, very well. That is it. It's not difficult at all. It's very understandable. And know that this is not what? This is not the diameter. It's not the diameter. And then we said that all the vertices of the triangle formed by the chord must touch the circumference. All the three vertices of the triangle formed by the chord must touch the circumference. So if any vertex does not touch the circumference, then that is not the alternate segment of theorem. Okay, thank you. I hope you are enjoying, you are following. This is get understanding, don't memorize. Yes, you want you to get understanding in what that you are learning. So this is what a tangent and what diameter or tangent and radius. And then you also saw that the tangent and what the diameter meet at what? Right angle. They meet at right angle at 90 degrees. And then the same tangent and what? Tangent and radius also meet at what? 90 degrees or right angle. So this is the center, this is the radius, and this is the diameter. So yes, don't forget about that. Also this one. So this theorem, this is the theorem 6. And this one is the theorem. So when you consider the theorem, we notice these properties of let's say triangles and chord and those things that we can also meet in what in circuit theorem that it can be seen, and then that can come in circuit theorem that are very useful in solving questions in circuit theorem. So we said that this one is not a theorem per se, so we just added this explanation in addition to this theorem this theorem this theorem 6, and we said that the triangle formed by two radii and a chord is always what isosceles. So this is a chord, and this is the center of the circle. This line is what is radius, and this line is radius. So any triangle formed by a chord and two radii of a circle is always what isosceles. You know what isosceles triangle is? This length is equal to this length. Therefore, the base angle, these base angles are equal. And then we also said that this is a chord. This line is a chord perpendicular bisector of a chord, always passing through the center of the circle. So this is the chord perpendicular bisector. We are perpendicular bisector means you are dividing this chord into two equal parts. When you divide this chord, this perpendicular bisector line, the bisector will make an angle of what 90 degrees with the chord. So this angle is what 90, and this angle is 90. And you divide the chord into two equal parts. So this length is equal to this length. The same way, if you extend, you see we have extended a dotted line from this point to this, which is radius, and from this is also radius. So if you don't bring that, that is okay, fine. Then that will be a perpendicular bisector of the chord, and then to make an angle of 90 degrees with the chord, that perpendicular bisector, and then to pass through the midpoint of the chord. So the distance, this length will be equal to this length. But if you extend this to also meet at the center, then it means that this one will be radius, this one will be radius. Therefore, this triangle will also be what isosceles. This one will also be what isosceles. There's one more thing that we also need to note. This is what an isosceles triangle. And then we said that isosceles triangle has one line of symmetry. So this line of symmetry divides the triangle into two equal parts. So this side of the triangle is what is congruent to this is equal to this side of the triangle. So we can hold this side and come and flip it or come and put it on this. And this symmetry or perpendicular bisector, if you like, you are dividing this one to divide this angle into two equal parts. This to divide this angle into two equal parts. This line to divide this. Now, if this is 30, then this one will also be 30. Okay. So this side, sorry. So this is since this is associated and this side is equal to this side. Therefore, the base angles are also equal. And this line of symmetry will also make an angle of 90 degrees with the base of the triangle. So this length will also be equal to this length. So these are the key and important geometric properties of triangles, chord, and those things that we have also learned and noticed. We meet them in circuit theorem, so it's very, very important. Also, this is theorem 7. The theorem 7 just talk about what? Two tangents. If you have a point, this is the point P outside the circle, and these two tangents PL and PM are drawn from this point. Then the theorem says that the length of this tangent and this tangent are equal. So it says that what? Two tangents drawn from a point outside the circle to the circle are always what equal in length. So this is equal. This length is equal to this length. That's why we have this. And then we went on to look at these angles. The angles in this how do you call it? In this figure that will be formed by the two tangents. And then if this is the center of the circle, if you extend this line to go and meet the tangent, then this line is the radius. And know that we have already considered that tangent and radius meet at right angle. So this angle is 90 degrees, and this angle is also what 90 degrees. This radius, this length is equal to this length. And then we also proved that this the two tangents are equal. I hope you prove that. And then we prove that this line, the line that joins the center of the circle to the point where the two tangents are drawn, divides the angle between the two tangents into two equal parts. So this angle is equal to this angle, and it also divides the angle between the two radii into two equal parts. So this angle is also equal to this angle. And then we also said that since this is a quadrilateral, LOMP is a quadrilateral, and this angle is 90 degrees, and this side is also 90 of the quadrilateral is 90 degrees. So this angle and this angle will give you 180 out of the total angles in the quadrilateral. But quadrilateral must add up the angles in the quadrilateral add to 360 degrees. So if this angle and this angle are giving us 180, then definitely the two remaining angles must also sum to 180. So we also prove that this angle and this angle they add to 180 degrees. I hope you remember. Yes, that's very powerful. Then we also from this theorem we also drew this diagram that there could be an instance whereby the two tangents. You join the two tangents, It's a chord. This chord will join the two tangents, and then we said that in that case, since this side, this tangent is equal to this tangent, then the triangle that will be formed. This triangle formed by this chord and the two tangents will be what? Associate triangle. Therefore, this angle will be equal to what? Will be equal to this angle, because those angles will be the base angles what in this associate triangle. And then we also said that if this chord and the two that will also form what? An associate triangle. Obviously, form an associate triangle because this is radius and this is radius. So it means that this side is equal to this side, this being the radius, and therefore this angle here will be equal to what? Equal to this angle, which will be the base angles in the what? In the associate triangle. So that is what we said. And then don't forget that this angle plus this angle will also give us 180 as we explained. So basically this is what? This is the summary on all the theorems that what we have considered so far. So these are the theorems that we'll be using to solve all the questions that will come on circle theorem. So we have to know these theorems very well. Don't have to memorize, but have to understand. Because in your wisdom is your understanding. And your understanding is your wisdom. Sorry, in your wisdom is what your understanding is your wisdom. Your wisdom is you understand. If you don't have understanding, you don't have any wisdom. That is why this channel is called understand. Get understanding, don't memorize. That is it. So thank you, and see you in the next video. So if you have any comments, any difficulty, further, any difficulty, let it come. Keep it coming in the comment section. Don't forget to subscribe to the channel. Hit the bell notification icon so that you'll be notified if any videos are uploaded in, so that you'll be notified to come and then look at those videos as well. Thank you for watching, and see you in the next video.